Problem 612, you have a projectile that's shot upward from the Earth, reaches a speed of, well, it has an initial speed of 20 meters per second, and they ask you to use energy considerations to figure out how high the projectile is when the speed is 8 meters per second, ignoring air resistance. When that says using energy considerations, that means to use the work energy equation. Now, what you can do is have a diagram that has the before and after scenario drawn. So initially you have this, the object moving up. You can assume that initially the height of the projectile is 0. You can just call that the 0 reference line. You're asked to figure out what the final height is if the final velocity is 8 meters per second. And so this is after. Before down here and after up there. So which one of these terms in the work energy equation are 0? Well, I guess you could say that the initial potential energy is 0 because you're calling that height 0. That's arbitrary. You get to choose what the height is initially, so I'm choosing it to be 0 so that my potential energy here is 0. Because it says ignore air friction, you can say that the work is 0. That is because the only other force besides friction could be that due to gravity. Well, it is gravity. That is one of the forces that's acting on it. There's no friction here. But the reason why we don't put gravity in here is because we've already accounted for it in our potential energy. We're going to use mgh for the potential energy. So this is the work done by all forces except gravity. And since there's no other forces, we'll call that one 0. So looking at this initial kinetic energy term, you can say mg initial, 1/2 mv squared. Sorry about that. M, the mass of the projectile, g, and then height at the final position, plus 1/2 mv final squared. You'll notice that in the problem, they don't tell you what the mass of the projectile is. And that probably means that it's going to cancel out, and that's exactly what happens. Dividing all terms by m, you see that you can solve for the h. Let's look at their solutions, and looking at that looks kind of similar. They do it a little bit different. They don't assume that the initial one is 0, but we can, and basically if you do that in their solution, you'll find that the final height is 17 meters. We could do the same thing here. In our solution, the final is equal to 1/2 mv initial squared. Oh, I said I was going to cancel out the masses. I forgot to do that. So v initial squared minus 1/2 v final squared. Moving this to the other side gives me the minus sign. Divided by g. You can see that's exactly what they have right here. They put the 2 down there. So 2 times 9.8, and then we have the initial velocity squared. Oh, well, they have a minus sign term right there, so ours is a little different. We have our initial velocity is 20, and we have that as positive, and that's what they have there too. So they have had a different sign convention, but they would still get the same number that we would, because we have a minus, and then we would have the 8 meters per second squared there. They have the same thing there. We would also get 17 meters above the ground is where the velocity is equal to 8 meters.